1, section 1.4, perimeter area in the coordinate plane. Example 1, classify each polygon by the number of sides. Tell whether it's convex or concave. So let's take a look at this polygon. 1, 2, 3, 4, 5 sides. So it must be a pentagon. I can draw a diagonal that goes outside of this. I can't draw a diagonal that goes outside of this polygon. So this polygon is convex. Okay, part B, let's count sides again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, making it a dodecagon. And I can draw diagonals that are outside of this polygon, making it concave. Part C, 1, 2, 3, 4, 5, 6, making this a hexagon. Again, there aren't any diagonals that are outside of this, so it is convex. Count sides here. 1, 2, 3, 4, 5, 6, 7, 8, making this an octagon. And again, we have a diagonal that is outside of the polygon, which makes it concave. Example 2. Find the perimeter of triangle PQR with vertices 1, -1, 4, 2, 4, and 2, -1. To answer this problem, I'm not going to draw it. Sometimes we graph them. I'm not going to graph this one. But I do need to find the distance from point P to point Q, from point Q to point R, and from point R to point P. So I'm going to distance formula 3 times. Distance equals square root of 2 minus a -1 is 2 plus 1 squared, plus 4 minus 4 squared, square root of 3 squared, or 3. That's our first length. Going from Q to R, 2 minus 2 squared, plus -1 minus 4 squared, -5 squared, square root of -5, 5. And the last one, distance equals, let's go square root 2 minus a -1 becomes 2 plus 1 squared, plus -1 minus 4 squared, square root 9 plus 25, square root of 34, which, when we pull out our calculator, approximately equal to 5.8. And when I add that to 3 and 5, it gives me a perimeter approximately equal to 13 0.8 units. So we have perimeter approximately 13.8 units. Okay, part B. Find the area of triangle ABC with vertices -1, 3, 3, -3, -2, 3. This one I am going to sketch quickly. You'll see why. A second, this is point A. Point B. And point C. Here's triangle ABC. Area formula for a triangle: 1/2 base times height. 1/2. My base is from B to C, so 5 units. And my height is from A down, making a right angle, so we can count spaces here. 3, 6. Gives me 15 units squared. Or 15 square units. That's part B. Part C. Find the perimeter and area of a square with sides 6 centimeters. This one I can do over here. 6, 6, 6, 6. Perimeter 4 times 6. Perimeter equals 24 centimeters. Area 6 times 6, or 6 squared, 36 centimeters squared. That's part C. Part D, find the perimeter and area of a rectangle with base 12 and height 3. 12, 3, 12 centimeters. 12 centimeters. So the perimeter, 3 plus 12 is 15, times 2 is 30. 30 centimeters. And the area is 3 times 12, or 36 centimeters squared. Find the area of triangle XYZ. Again, area equals 1/2 base times height. 1/2. My base is 30. My height is 13. 15, half of 30 is 15. 15 times 13, 195 centimeters squared. Okay. That leads us into part F here. Structural design. When designing a building, you must be sure the building can withstand hurricane force winds, which have a velocity of 73 miles per hour or more. The formula F equals 0.004 area times velocity squared gives the force F in pounds exerted by the wind blowing against a flat surface. A is the area of the surface in square feet. V is the wind velocity in miles per hour. How much force is exerted by a 73 mile per hour wind blowing directly against the side of a building shown here. So this building right here. So to do this problem, we need to find the area of this building and then plug that area into our formula and plug 73 into the velocity. Okay, so to find the area, we're going to find the area of this rectangle and the area of the triangle and add them together. So let's first find the area of the rectangle. The area of the rectangle is going to be 12 times 20, or 240 square feet. Area of the triangle is again 1/2 base times height. 1/2. Base is 20. The height is 6, giving me an area of 60 square feet. The area of the house then is equal to 300 square feet. And we're going to plug that into our force formula. So force equals 0.004 AV squared. 0.004 373 squared. And we go to our calculators. 0.004 times 300 times 73 squared gives me 6,394.8 pounds hitting the side of the house. That's the answer to part F. Example 3. Classify each statement as true or false. If two figures have the same area, then they must be congruent. That is false. We know that. Here's example 2, C and D. This square has an area of 36 centimeters squared. This rectangle has an area of 36 centimeters squared. And these two figures here and here are not the same. Okay. Part B. If two figures have the same area, then they must have the same perimeter. Again, same area, different perimeters. False. Part C. A square is a rectangle. True. Part D. To calculate the area of a rectangle in example 2, part D, you let the base equal 3 and the height equal 12. You can. In other words, I made the base 12 and the height 3 and got 36. But if I make the base 3 and the height 12, I'm still getting 36. Yes, I can. True. Okay. Find the area of each figure. A square with a perimeter of 10n units. So if the perimeter equals 10n, perimeter is equal to 2 times base plus 2 times the height. I didn't read the question carefully. It's a square, not a rectangle. So the square's perimeter is 4 times the side. So if I want to know what the side is, I divide everything by 4. The side is equal to 5n over 2. And the area of the square is equal to s squared, or 5n over 2 squared, 25n squared over 4 is equal to the area for part A. Part B, a square with side lengths 3m minus 4n units, and we want to find the area of this. So again, area of a square is equal to s squared. So 3m minus 4n squared. And if we square that out, we get 9m squared minus 24mn plus 16n squared. And then the answers to part A and B. And again, for part A, actually I should be writing units squared, and for part B, I should also be writing units squared. Example 5. The lengths of the sides of 3 squares are s, s plus 1, and s plus 2. The total area of the squares is 365. Find the value of s. So, I'm going to give myself a little bit more space here. Go down the bottom of this. So the area of the first square is s squared. Area of square 2 is s plus 1 squared. And the area of square 3 is s plus 2 squared. And all three, area of 1 plus area of 2 plus area of 3 is equal to s squared plus s plus 1 squared plus s plus 2 squared, and that's equal to 365. S squared plus 2s plus 1 plus s squared plus 4s plus 4 equals 365. 3s squared plus 6s plus 5 equals 365. 3s squared plus 6s minus 360 equals 0. Everything divides by 3. S squared plus 2s plus 120 equals 0. This factors s plus 12, s minus 10, which gives me two solutions, two algebraic solutions, s equals negative 12 or positive 10. But this is in geometry, so s has to equal 10 units because we're talking about the length of the sides of squares. So it has to be positive. Okay. Example 6. 2 squares, each with sides 12 centimeters, are placed so that the vertex of one lies at the center of the other. Find the area of the shaded region. So this is the center of this square here, which makes this a right angle here. And imagine if I take this square and I rotate it up. It's a little tricky. But instead of having this, we have this situation. So now the sides go through the vertices. Now the shaded region is here. And my quick sketch may be a little hard to see, but this is 1/4 of this area. This shaded region here is 1/4 of this square. And the square's area is 144. When we divide that by 4, so area of the square is 144 centimeters squared. If I divide that by 4, then the area of the shaded is equal to 36 centimeters squared. And that's all of the examples from section 1.4. Thank you.